Hello everyone, welcome to Compiler Design video series. In our previous video, I have already discussed about different terminologies like handle, handle pruning, different parsers like operator precedence parser, shift reduce parser, how to parse the string using operator precedence parser, what is LR parser, types of LR parser. There are three different types of LR parser: simple LR, canonical LR and look ahead LR. Among these three, CLR is the most powerful parser. Second one is LALR and third is SLR. SLR is easiest to implement and least powerful. CLR is most powerful but most expensive, and LALR is intermediate in power and cost between the SLR and CLR. So in LR into bracket K, we must be able to recognize the occurrence of the right side of a production, having seen all of what is derived from that right side with K input symbol of look aheads. So in a LR0 or SLR parsing, it's a simple LR. A grammar for which an SLR parser can be constructed is said to be an SLR grammar. SLR is a type of LR parser with small parse tables and a relatively simple parcel generator algorithm. It is quite efficient at finding the single correct bottom-up parse in a single left to right scan over the input string without backtracking. So the parsing table has two stats, action and goto. So the parsing table has four values: shift, which is indicated by S, reduce, which is indicated by R, accept and error. So in a SLR, first you have to generate augmented grammar. So what is augmented grammar? If any grammar G having starting symbol S, then augmented grammar is the new grammar G dash, in which S dash is a new start symbol such that S dash gives dot S. So what is the purpose of augmented grammar? To indicate the parser when it should stop parsing and announce the acceptance of the input. So sometimes terminologies are asked in exam like augmented grammar, viable prefix. Viable prefix is a set of prefix in right sentential form of the production. A gives alpha, that is, this set can appear on the stack during shift reduce action. Kernel items, so it is a collection of items. S dash gives dot S and all the items whose dots are not at the leftmost end of the right hand side of the rule. Non-kernel items, it is a collection of items in which dots are at the leftmost end of the right hand side of the rule. So first convert your grammar into augmented grammar. Here show with one example. E gives E plus T or T, T gives T star F or F, F gives F star or A or B. This grammar is given. So first convert this grammar into augmented grammar. Your main grammar is G, then your augmented grammar will be G dash. First E dash gives dot E. Just put dot before your starting symbol. So E dash gives dot E. After dot, you have find any non-terminal, then write its production. So here IDES gives dot E. So after dot you find one non-terminal which produce other products. So write that product. E gives E plus T, E gives T, T gives TF, T gives F. Just separate all this product. F gives F star, F gives A, and F gives B. So now find closure of I. So first your state is I0. So I0, it means IDES gives, just put dot before your starting symbol. IDES gives dot E. After dot you have non-terminal. So consider its product. Its product is E gives E plus T and E gives T. So E gives, just put dot before every product. Dot E plus T, then E gives dot T. Here T is a non-terminal. It produces another product like T gives TF and T gives F. So write this product and just put dot before the product. Now T gives dot F. So F is a non-terminal which produce other products. So consider that product F. F gives dot F star, F gives dot A, and F gives dot B. Here you find non-terminal after dot. So write down all product of that non-terminal. So F gives dot F star, F gives A, and F gives B. Just put dot before all production. Now you have to move this dot. So next state will be I1. So I1, in I1 go to I0 to E. In your I0 product move dot after E. So before E you have these two production in which you have a dot product. So IDES gives E dot, then E gives dot plus T. IDES gives, here move this dot to this non-terminal. So IDES gives E dot and E gives E dot plus T. So just move dot before E. Right hand side production in which you have dot before E, that all dots are moved. So IDES gives E dot and E gives E dot plus T. Next, here these two products are already considered in which we moved I0 to E. Then after next state, so state number is I2. So move I0 to T. E gives T dot. Then second product for T, T gives T dot F. Here after the dot you have non-terminal F. So write all the product of that non-terminal. So F gives dot F star, F gives dot A, and F gives dot B. Write all the product of this non-terminal and put dot before all the product. Next, this T is already considered. Next move I0 to F. So next state will be I3. So T gives F dot, and here also F produce. So F gives F dot star. Next move from I0 to A. So F gives A dot. In other production of I0, there is no any other non-terminal A except this one. Next move go to I0 to B. So F gives B dot. So these all productions are used. Now next production is I1. So move go to I1 to, this is the complete product, so not considered that product. So next is I1 to, this dot is moved after plus. So go to I1 to plus. So your product will be E gives E plus dot T. E gives E plus dot T. Here after the dot you have non-terminal T. So write the product of T. So production of T is T gives TF and T gives F. So just put T gives dot TF and T gives dot F. Here after dot you have another non-terminal. So consider that non-terminal product. So write F gives dot F star, F gives dot A, and F gives dot B. Next, this production is complete. So next I2 to move F. Here this production is complete, so no need to move dot for this I2 to F. So in your I2 production, dot is moved after F. So T gives TF dot and F gives F dot star. T gives TF dot and F gives F dot star. Next I3, this production is complete, so move I3 to star. So go next, this sequence is continue I3, I4, I5, 6, 7, 8. Go to I3 to star. So this dot is moved F to F star dot. Next I4 is a complete product, I5 is a complete product. So next move to I6, I6 to T. So your product is E gives E plus T dot, T gives T dot F. Here after dot you have non-terminal, so use its product. F gives dot F star, F gives dot A, and F gives dot B. Next I7 to star. So you got I7 to star. So your product is F gives F star dot, which is already pointed by I8. So I7 to star is I8. Next I9 to A, it's a I4. I9 to A, so you got F gives A dot, and I9 to B you got F gives B dot, which is already indicated by I4 and I5. So go to I9 to A, I4 go to I9 to B, I5. Here I2 to A, F to A dash and F to B dash, which is already indicated by I4 and I5. So if you find any repeated state, then don't give any new name, just repeat that state. So this is your LR0 collection. According to this collection, you have to draw parsing table. So SLR parsing table, there is mainly two part, action and go to. In action, you have to write different states which is identified by I0, I1, I2. So in this case, we can find I9, I0 to I9. So your state will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In action, you can use all the terminal of given grammar. So use all this terminal plus, star, A, B. These all terminals are used in action. At the end, add $sign. In the go to, you have to use all the non-terminals of a given grammar. Here in this grammar, E, T and F, three non-terminals are used. So write E, T and F. For parsing table, you have to check all this LR0 collection. Write down from 1 to $, always accept, because it's a augmented grammar. So in first state, you can find this grammar. Your parsing string will be accepted in the first state. So always put accept from state 1 and input symbol $sign. Now for next entry, you have to check I0 to E. State is I1. So write 1 in go to state. I0 to E, you find I1. So just put this number into go to state on a 0 state row. Next, I0 to T. So your 0th row and T column state is 2. So just put 2 on this column. Next, I0 to F, state is 3. So 0 column F, write 3. Next, I0 to A, state is I4. So write its shift entry, and I0 to A, write S4. I0 to B, so 0 to B. So in this column, write shift entry with number 5. So write S5. Next, 1 to plus. I1 to plus, it's a I6. So 1 to plus, it's a S6. Next, 2 to F. Second row F, state is 7. So just put 7 into this go to state. Next, I3 to star, I8. So in a third row, 3 to star, put S8. 3 to star, push is 8. Next, I6 to T. 6 to T. It's a I9. So write 6 to T. It's a 9. So just check all the product. You have to repeat this process until you can find all the dot at the end of all production. If any product is find repeated step, then go to that repeated step number for that product. For reduce entry, you have to find follow product. For reduce entry in a SLR parsing table, you have to find follow of given non-terminal. So find follow of given grammar. So follow of E is plus and dollar. Follow of T is plus A, B and dollar, and follow of F is plus star A, B and dollar. So for reduce entry, check all the complete product. So in which state you can find reduce entry? Here E gives T dash. This is complete entry. So complete product in second state. So put that in second row. Then find follow of this non-terminal. So follow of E is plus and dollar. So in a second row, write reduce entry in plus and dollar. Then which number you have to give? For that you have to check augmented grammar and indicate it by numbering like 0, 1, 2, 3, 4, 5, 6 and 7. So your E gives T product is at second position. So give R2. For reduce entry, you have to check complete product. In this case, first in the first complete product is E dash gives E dot, which is your augmented grammar. So in a $1 we can write accept. Next complete product is E gives T dash. So write down in a second row. This is state I2. So in a second row you have to write reduce entry. At which column you have to write reduce entry? For that you have to check follow of this product. So follow of E is plus and dollar. So in a second row, plus and dollar, you have to write reduce entry. Then which number you have to write here? For that you have to give number for augmented grammar and at which position this product is given. Second position, E gives T. So you have to write R2. Next, for third row, it's a complete product. T gives F dot. So you have to write reduce entry in a third row. In which column? Follow of T. Follow of T is A, so B plus and dollar. Follow of T in a third row, plus A, B and dollar. So in this 4 column you have to write reduce entry. So which number you have to give? your product is T gives F. So T gives F is at 4th position. So you have to write R4. Next, F gives A dot. So in a 4th row, you have to put reduce entry in a follow of F. Follow of F is plus star A, B and dollar. So plus star A, B and dollar. In this column, you have to write reduce entry, and which number is given? F gives A. F gives A is at position 6. So thus you give R6 at this position. Next, F gives B dot. So write down at 5th row. At the 5th row, you have to find follow of F, which is plus star A, B and dollar. So in a 5th row, you can write plus star A, B and dollar. F gives B as R7. So you can write R7 at this whole column. Next complete product is, in this there is no any complete product. So I7, T gives F dot. So in a 7th row, you have to do reduce entry for follow of T. Follow of T is plus A, B and dollar. So in a 7th row, plus A, B and dollar, you have to write reduce entry. T gives TF dot is a product at 3rd position. So write R3. Next, F gives F star dot is a complete product at 8th row. So in 8th, find follow of F, which is plus star A, B and dollar. So plus star A, B and dollar, you have to do reduce entry. F gives F star is at position 5. So R5. Next is E gives E plus T dash at 9th row. So in a 9th row, you have to put reduce entry at follow of E, which is R plus and dollar. So put R, and E gives E plus T is at position 1. So write down 1 at in reduce entry. So thus you can put shift and reduce entry in SLR parsing table. So this is the simple LR parsing table. According to LR collection, you have to parse all the shift and reduce entry. It may be possible to conflict in SLR parsing table. There are mainly 2 types of conflict: shift reduce conflict and reduce reduce conflict. So in sometimes there is 2 entry in a single column, like shift and reduce. So both entries are in a single column. It's a conflict. In a shift reduce conflict, you have 2 possibilities for either shift or you may reduce the product. And second one is reduce reduce conflict, in which you have 2 same input production, like A gives A and B gives A. So whenever A will become, at that time you have a 2 option to replace that input symbol, either A or B. So it is known as a reduce reduce conflict. So this is your simple LR or LR0. In your exam, there is any grammar, according to that grammar you have to draw LR0 collection and SLR parsing table. First you have to convert given grammar into augmented grammar. Then after you have to find closure of I. After finding the closure of I, you have to draw SLR parsing table. In SLR parsing table there are mainly two parts, action and go to. In action, different input symbols of a given grammar, state and $sign, and in a go to, total number of non-terminals which are used in your grammar. So thus you can construct SLR parsing table. Thank you.